Okay, so let's move to so all those fancy techno. So how it affects our daily jobs? Okay, we find some popular item on the ST and let's try. And
Yeah.
the first one is the chopping board engraving. Okay, let's go to the and also we decide to show you how I operate the machine directly. Yeah, we decide to show you the early stage prototype and we partner for the software. We partner with Liban and the software will the user will only need to learn the new software. Right now we are using command line and the control UI interface. It's not ready it's not ready yet, but I want to show you the early status so that can help you clean out the concern. Okay?
Yes.
Yeah.
So now David will prepare the chopping board engraving. So I think this is quite common
This one
use
is a
case.
use case, and we're gonna engrave an image this size, and we will have a close camera to show it in action, and I will operate. I will show you how I do the engraving. Yeah. Yeah, yeah.
So we'll have a zoom in camera to help you see the details.
Okay, okay. You can uh, right corner. You can show my screen. Okay.
Okay. Yeah. And we'll
And
also show you what is going on the computer in the software. So this is the not the final UI. Is the developer version of the controller. And just like David mentioned, we are working with Lightburn, and Lightburn will be 100% compatible with Excel Laser. So this is the version we will show you here, only here.
yeah, and I have done I have put the stock and set the origin, and yeah, we will have a dual camera system to after the software was polished, we will have a dual camera position system to position the workpiece. And right now I align the workpiece, and let's get started. Let's show you. Let's see in action. Yeah, and. Let me check. 420. Okay. Okay. Wish me good luck.
So the size of this use case is around 230 by 230.
Okay. This one is running the. Yeah, we will talk about it later about the vector resting engraving, and yeah, let's see in action. Yeah, and this kind of movement get the benefits both of vector engraving and the raster engraving, and it have the laser source active most of the time. You don't do much of jogging, and you can see the spot the light spot size kind of like changing size is actually the gavel doing a very fast scanning. Yeah.
Yes.
Yeah. It's entertaining to watch the engraving. I hope you like it. Yeah.
Yeah. And actually, it's hard to achieve by other gantry laser machines because only the Galvo can defocus like this and engrave the line with different widths. And we will explain that a little bit later as well.
How
So
tight is the dial beams is going through? We require the gavel. Yeah, yeah. Dave, you asked a question. So the dial beams. We have the laser source. We're gonna talk about in detail later. But the laser source, the beam quality of the laser source is equivalent with the 20 watts in the market, which is one of the biggest achievement of our machine. You know what? When we launching this product, the market didn't seem to give enough attention to our diode laser. So today we will mainly focus on diode laser. So the diode laser kind of a misunderstanding in the market for a while is people get used to CO2 glass tube machine, and the advantage is cutting and especially cutting clear acrylic. But for wood engraving, the diode laser can engrave much darker and get a better effect. And also the maintenance is much easier. And the lifespan, I would say, for the I think there are two kinds of CO2 laser source. For the glass tube, you cannot do high details engraving. The small size and also the way it generates laser source, it cannot open and shut down in the high. And that's yeah, that's
Yeah, it's
yeah,
done.
it's done. Okay, and yeah, yeah. Yeah, okay. I didn't put it in the center, but yes, this one took, let me see. This one took,
Around 2 minutes.
this one took around, I believe, I don't, yeah, 2 or 3 minutes, 2 or 3 minutes. And normally, this kind of engraving, normally this kind of engraving took 20 to 30 minutes easily with traditional gantry machine. Okay, okay. This is how fast this type of motion system. Yeah, yeah.
Yeah.
Yeah, and yeah, yeah. Let's continue about the CO2. So CO2, the advantage of diode laser is engraving. Yeah, and yeah, actually, diode laser is for me is like a electricity car versus a fuel driving car. It's not a one superior than other. It's about your use case.
Yeah.
I hope that makes sense to you. And what we achieve a very high voltage, and the in-depth beam quality is the most hard engineering task. So I think most people pay attention to the fiber MOPA, but actually diode is what our killer application. And let's go to that later. Okay. And this is the first demo. I hope you like it. Do you have another demo? Let's do another real life job, a door sign engraving.
So this use case is the door sign engraving. So we see a lot of essay listings, and I think this is one of the most popular products on Etsy. And many small business owners also use this product.
150 and 50, right? See the
And the size of this use case is around 220 by 113.
Okay, I'm gonna do the rehoming. Yeah, I'm gonna. Yeah, you can see me operate the machine because I see the homing position isn't right, so I rehoming the machine and doing the right right Z height, And I believe all these will be, when we finish, all this will be done by the machine automatically. And at this stage, why we didn't let Michael operate the machine is that we need to, yeah, it's kind of like a software engineer, and at this stage, yeah, and still need to some trick behind, yeah. And let me show you.
So let's see what you guys have questions. Yeah, I believe some of you mentioned the laser spot. So the laser spot size is different in the Pro and in the Ultra version. So
Okay, ready for the second one. Is a door sign, and yeah, right.
here we go. So we just started the engraving. So the spot size for essential is smaller. It's like one of you mentioned. It's 0.08 by 0.06 millimeter.
Exist. Yeah,
and for the
yeah.
Pro and Ultra,
let's have some question, and yeah.
And it's a little bit bigger, 0.1 by 0.1 millimeter, both of Pro and Ultra.
Okay, it's in action. Can you see it working? Yeah, yeah. So we have a multiple strategy to doing the engraving. It will analyze the input files and find the best strategy fits, easy fits for the engraving, and for best performance and for best results. Yeah, you can see sometimes it's doing the vector resting, and sometimes it's doing the just raster, and yeah, we're trying to come up algorithm that maximize this kind of setup, hybrid motion one. This is a new motion system. So normally when you have let's say I come from 3D printing industry, yeah, and we have done one thing that we ship out a machine from 2016 to 2017. 5 years later, we upgrade the firmware, and the system boosted, the speed boosted, and that's how motion system matter. When you have a new hardware, you need to analyze the characteristic and optimize in the motion system, optimize in the software system, which Liban teams is very great. We're gonna we're gonna collaborate with them and figure out how this motion system should be improved. So the current state isn't is fully this stage is like we having this style of a machine, and we are optimized motion system, and we are improving the software. It's gonna be better and better. The performance haven't reached its limits yet. Yeah.
So Jeff mentioned that please confirm the machine model. This demo is on.
Okay, so the center stage is for Pro today. So enough attention to Ultra. Actually, we think the Pro version is yeah, the Pro version is yeah, deserve more attention. Yeah, and also some use case, real life use case needs more attention, and diode laser need more attention, because actually I would say we spend 80% of our time in diode laser. To be honest, to be honest, yeah, yeah, and let's go. Will the higher end version Ultra need a cooler like CO2 since it's high power? Yes, yes, and yeah, the Ultra version is the water cool, and we also have a good news to announce later for the Pro as well. Yeah, yeah. It's because it's high power. Without the water chilling, the cooling, the air cooling will like kind of like how to say, it's like in the lab during the last live, okay, it's done. During the live stream, people will say the noise is like a jet engine. Yeah, it is for those much of heat distributed with air is very noise, and we optimized it, and we decided it should be quiet, and so it's water chill. So okay, let's see the result. Okay, and yeah. Yeah, yeah, cool. Okay. So can you see the work
Details.
pics? Yeah. Okay. Yeah. And for the I see a lot of question about the air assist. Yes, here is how we design the air assist. You know that we see this product is a design decision. Yeah. We can have a built-in air assist for the sake of the simplicity and for the convenience. But for a professional grade machine, you might want some flexibilities.
Yeah.
Because some users have already have their like big one, industrial one, and even the industry have evolved from the simple one. So let's get another demo about large format photo engraving.
Yeah, photo engraving.
Photo engraving. Okay, engrave in this wood stock. Okay.
And remember to stay with us. The giveaway will be after the demo demonstration. Okay, let's check it out.
And yeah, we're gonna talk about this technology is working, and this is another interesting interesting algorithm. You can see is engraving stripe by stripe and stitching them together. And yeah, we call it seamless panelization stitching. Yeah, and the image was panelized, and yes, and just like session engraving, we stitch them together, but seamlessly, and it's doing the machine is doing the engraving, and I trying to explain a little bit about the engineering task we face. Okay, so first of all, to do the First of all, when we are trying to tackle this problem, you need to have a accurate motion system. You say when it's perfect, it can stitch together.
Yeah.
But a complex system like this, perfect is never possible. I would say perfect is never possible. Yeah, and so you have a multiple layer to address the question. You can have premiums, premiums, bearing, premiums, motor, and premiums linear rail. This is the hardware, and you can have a great firmware. Motions like we do. We have a multiple sensor and multiple compensation algorithm to make sure we measure the error, predict the error, and compensate the error. Okay, this is how we do it. And also in the software part, you guys know about the image R, right?
Yeah.
It's like a magic when you throw the image to the software and the result getting better. So is multiple layer engineering task. So what we want, what the task ahead of our engineering team is, you put a stock, you have input file, and a bump, it gets a perfect result.
Yeah.
Yeah. And I think we nail it. We nail the speed and we nail the quality. And yeah, it's still engraving.
Yes, and
Yeah.
you can see it's scanning strip by strip. So it's like sections
See some
sticking together.
questions. Okay. And I understand correctly about the water cooling of the moped. Do you have to fill the water into the machine, or is there a hose you have to submerge into an external container? No external container is in the water chiller, but the water chiller is external unit, not inside the machine.
Yes.
Okay, okay. Uh, so Jenny, you're gonna answer how to enter the giveaway.
Yes, so when we start a giveaway, you just need to enter some keywords we give you, and then the tool will pick randomly one of the users who comment the keyword correctly, and that's the winner. So please watch the video live stream along, and we will start the giveaway after the demonstration.
Yeah, and the CO2 definitely win in the acrylic and in cutting. In cutting, yeah, CO2 laser is great. They are different, and the dial laser excel in engraving. It engrave darker and have a better effect because CO2 machine cannot open close the switch that as fast as dial laser. It's just the limitation of the hardware. Okay, and so the engraving high definition image or engraving on wood, the dial laser excel. Yeah, just like I said before, it's just like an electricity car versus a fuel driving car, fuel car. Okay, and yeah, and CO2 especially used for clear acrylic. This is very important use case.
Yeah.
And for the wood, for leather, for most of the engraving, I would say dial laser doing better. If you compare with glass tube, is much better. Okay, and are there any heat problem or why he touches again the laser? I'm not sure I get your point. Okay, this. Okay. Are DWG files supported? I'm not. I think Library support those files. Most of the files. Okay. How fast the machine is? The gavel runs at 4,000 millimeter per second. For comparison, in the market, gantry machine can reach to 600 or 800. But you should notice that most of the time, machine have to accelerate to reach that speed.
Yeah.
So the speed is one important spec, but acceleration is making the difference because you see, for most consumer machine, the acceleration is 1,000 to 2,000, and our machine is is 500,000 to 800,000. Yeah, yeah. It's totally different machine. If you want to compare the, okay. Let's not go into spec too much. Okay, and is the switch between dial and the fiber physical of the software. The switch is software control, and you can do it in one job, switching the fiber and switching the laser source.
Yeah.
And yeah, is it possible to limit the angle of laser use the gantry only? Yeah, of course. When you do cutting, we have air switch nozzle, and when you do cutting, you don't want to have those angle too much. Okay. Does the machine have a lot of holes inside the machine, make the cleaning difficult? Yeah, the cleaning, what we're trying to minimize the maintenance. Yeah, and we want the protective lens. We want to design an air curtain flow to make it job by job or weekly maintenance to monthly maintenance. And the lenses for camera, and we still design the airflow for better maintenance experience. Those lenses need to maintain time to time, but with proper design, it can be minimized. We are striving to make that happen. Yeah, yeah. So this can cut wood and metal. Yes, this 80 watts fiber laser can easily cut 15 millimeter wood, and yeah, and the metal for a thin metal, 60 watt motor is capable machine to do that. You have been working a lot with Liban as the okay. So we are working with Liban, and Liban is is a great team. Is a fun to work with them, and the user. I think the software is software. The community around the software is very important. Building another software for a premium machine like this one is not reasonable from my perspective, because as an engineer, we don't. From my standpoint, I don't want to reinvent the wheel.
Reinvent the wheel, yes.
And Liban build the best wheel. Okay.
Yeah.
Okay. Okay. Let's see the results. Okay. Okay.
Yeah.
So you guys see the results is image engraving, large format image engraving. I believe this one took about 8 to 9 minutes.
Yes.
But with ultra, with a proper setting, it can reach to 5 minutes. 5 minutes for this one is almost took the whole workspace in the 300 by 400, I believe, or 500, 450. Yeah. Yeah. Three job, one job 3 times.
Yes.
Yeah. The first one is for comparison. The first one is without the compensation, just the stitching them together. The second one is with the compensation, etc. And the third one is I will deliberately make it uneven and make a slope and have the LiDAR working for you. And we want to show LiDAR for you and how it works during this engraving job, and enjoy it. And the first one is for comparison is just stitching them together. Yeah. Okay. Yeah. He said he's choosing to see it. Yeah.
Yeah.
Yeah. Yeah. Yeah, and you always get, yeah, this is the first time I on a live stream. I watch a lot of live stream. It's very fun to watch a live stream. Yeah, yeah. I believe the machine isn't in its perfect state right now. Yeah, but I think it's okay. We can move forward. Yeah.
So this one is the casually put on the machine, right?
Yeah, I just put a light sensitive paper. We normally use those paper to test the accuracy, the precision. So this one, and we do photo engraving, high definition photo engraving to show the artifact. This one is to show the artifact without the compensation, without the compensation, without the bell and whistle, and just show you how we manage to tackle the engineering task to make it easy for everyone to use. Okay, so the table is not that even. So let's get back to the engineering task. When you want to stitch perfectly, you have premium machine move accurately. But another important effect is the stock, the workpiece. It's never gonna be that even.
Yeah.
Yeah, because
Never
the
perfect.
wood, the paper, and when you have heat, it will warp. It's a, it's a, I hope that makes sense because yeah, in this scope group I discussed with Becker that they want to emphasize how important about the machine. Yeah, I share some thoughts that
Yeah, it's done.
yeah, it's done. Yeah, yeah.
So you can see that there is actually lines between the strips.
Can you see this one?
So that's without compensation.
Uh, okay. Can you guys see the artifact? Yeah, give us a feedback, please.
Yes, that's obvious. The gap is obvious.
Okay, okay, and this is high definition photo engraving. Okay, okay,
So that's the comparison we want to show you.
and yeah, and I put another into the yeah. Let's
Yes.
get back to the homing position and open all those, open those compensation. Yeah, yeah. This is the second job. With this second job, I want to engrave the same image and
With compensation,
with
right?
compensation, with
Yes.
the compensation on, and there you see the difference. Yeah, as you can see, every you are back. They have engineering degree. They want to. Okay, okay. Okay, longevity. Yeah, I see your point. I see your point. Yeah, and I can see multiple optimization in different level for the hardware, for the sensor, and for the motion system, the firmware, and for the software. And yeah, in multiple sensor, I would say multiple sensor. You see, the accelerometer is the closed loop, and the camera is the closed loop, and I would say multiple sensor, multiple data, and in combine, provide the error prediction and error compensation. Yeah. Can the red lines use for positioning, and does this? I believe when the product is polished, we want a single best workflow is dual camera. Yeah, because sometimes if you have a multiple choice, you get confused. But we always will have an option there when you are sure you want to use it. But the best workflow is it's kind of a different paradigm. You see, when you have a computer, you want the feature to be laid out. But when it's easy to use enough, when the software industry involved, when you have a right now the iPad have the best user experience from my experience.
Yeah.
Yeah, yeah. So I hope that answer your question. Yeah, and yeah. So yeah, the red dot is there, and if you want, it's there, but we prefer the dual camera positioning system.
So why are we engraving the same image the second time? It's
Yeah.
because we want to compare the results and show you the results.
No, he is saying that why he have multiple paths. You see, this is the multiple algorithm, multiple strategy we implement to make sure the quality. So it's one of the strategy we choose. We analyze the input and chose the right strategy to do the job.
Yeah.
Yeah.
And what's the time difference?
Will be the time difference in time, almost no difference. Almost no difference. Yeah. Yeah. As you can see, the laser just override. Yeah, yeah. People are guessing how we did it, and yeah, we like to share. Yeah, let's see the results. Okay. Okay. So this one. Yeah.
Yes. No stitching error.
Yeah. I can assure you with holding in hand and having a lens to zoom up, you cannot see the visual artifact. Okay, and this is the one without the compensation.
Yes.
Okay, can you see the two together?
Yes, this way is better.
Okay, can you see the two together?
Yeah. So that's the improvement we did.
Yeah. We like. Hope you like this one. Hope you like this one. And yeah. And this is how we claim that is for everyone. You don't need to the machine take care for you. The machine take care for you. You have multiple sensor and multiple algorithm strategy implement, and I believe it's very hard to find yeah, is impossible for human eye. Yeah. Yeah.
Yeah.
Okay. Okay, and I want to add another task for this one. Is yeah.
Is to put the stock uneven.
Yeah. Yeah. I want to demonstrate is this one. This one is 10 millimeter, 10 millimeter thickness, around half, uh, one third inch, yeah, and one third inch, and yeah, ooh, and let's see how LiDAR work, and this one, and yeah.
So David is putting a wood with 10 millimeter width under the paper.
Yeah, it's important because you see in the real life use case, the wood is never be that flat. You buy wood from different sources, and with heat, with humidity, it will get warped, etc. And yeah, let's open the lid and let's do the bed level. Let's let the high speed ranging work, and yeah.
So
Yeah, how it works is right now is measuring the table, and make sure it's yeah, it's just like the user mentioned before. It reconstruct the table. Yeah, yeah, and with this intentional warp, we can still stitch them together. Yeah, and I would say normally for a wood, if you warp 1 millimeter, we can manage to do that, and with the slope, we can do that. That can handle, I would say, most of the situation. Yeah.
So after this demo and a few more minutes
Yeah,
of the product update, we will go to
it took about a minute or to measure the workpiece, and yeah, let's start the job. Yeah, let's see in action. Sleep now and you will miss the X. Okay.
Yeah, it's quite late in Europe.
Okay. Odds are pretty damn good for free laser. And what does this mean? Sorry, I did not.
Alex, that's Alex.
Yeah, Alex. I didn't follow yet. No. Yeah. Yeah, 3 is early in your call. Thanks for your attention and thanks for your support. Yeah.
Right now, RN, right now, family. Yeah, so I was just saying, like, if.
Okay.
So this one is also around 3 minutes.
Yeah, using this demo, you can see in action of the high-speed ranging works. And when you put, let's say you have a skateboard, no skateboard, some curved object, some geometry curved object, you don't need a 3D scanner. You just use the high-speed ranging. You can choose you can do the trade-off. You can measure every one millimeter, every 10 millimeter, and every 20 millimeter is up to you. But the higher the detail, the more time it consumes. So for this one, I believe we have 10 millimeter per probe, and it can per second it can have 50 points. So it's pretty fast. Okay.
Yeah.
And yeah.
So these two questions are similar, I think. What interval are the measurements taken, and how many points are getting measured per cm?
Square. Okay.
Yeah,
okay.
the
yeah.
interval.
I believe it's 10 millimeter. Am I right? 10毫米每个。Never mind. I think it is fast enough. You can see the whole procedure. Yeah.
Mm-hmm.
Yeah. So and it's up to you to choose if you want high definition, and you spend more time. And if you are busy, and you can do the raft. And I believe for wood, the raft 10 millimeter, 20 or 30 will be enough, because the tolerance, the whole algorithm implement the tolerance is good enough. Okay. Yeah, scape maybe too large for skateboard, so it's just something came to my mind. Okay, and yeah, APL and input shaping. Yeah, like I a little bit about me. I spent 7 years in 3D printing industry, and those technology will come from different industry, from from other consumer sector. Okay, let's see the result. Yeah. So this is the setup, 10 millimeter slope, and this wood is not perfect flat. We did not choose deliberately at all, and the lights sensitive paper, and can you see the result?
Okay.
Yeah. Cool. Let me know. Does that? Let me grab this one. Yeah. This one without compensation. And yeah.
Yes.
This one with the compensation. And this one with the slope and the compensation.